Hi everyone, my name is Kevin Ko. I'm an open source community engineer at Prefect, and today I'll be talking about dynamic workflow orchestration with Azure Data Factory and Prefect. So for today's talk, a lot of you may be, since you're in Microsoft Build, a lot of you may be familiar with Azure's Data Factory and its offering for workflow orchestration. Today we're going to show Prefect, which is an open source workflow orchestration tool, and we'll cover the basics of Prefect in terms of writing Python code. And then we'll show how it actually complements Azure Data Factory. It actually extends the functionality of Azure Data Factory. And here we'll cover three specific examples of that. One will be the dynamic DAG creation. Number two will be working with non-Azure resources. And number three will be execution of workflows in other environments. Before I dive into those, we'll talk a bit more about Prefect. So Prefect is an open source data flow automation tool that was designed for the modern data stack. I pulled these stats from earlier today, and we currently have 6,300 GitHub stars, and we have a very active Slack community with over 5,500 members. Prefect was originally designed by data scientists in order to with the intention of unifying data science and data engineering, making it easier to deploy and scale data-related tasks. Prefect is a Microsoft partner, and you'll find us available in the Azure Marketplace. The mission of Prefect is to eliminate negative engineering. When we talk about negative engineering, we're talking about defensive code. So stuff that people want to do, their main objective when they code, we refer to it as positive engineering. Positive engineering is the code that you write in order to get your task done. Negative engineering refers to the defensive side of failure handling, that positive engineering. So negative engineering refers to failure handling, like what happens if the database goes down, what happens if the code, that the machine that the code is being run on fails. We need to be able to handle those cases. From the initial reports of our market research, engineers spend up to 90% of their time on negative engineering tasks. And what Prefect aims to do is to drive that down so that people can actually code and do the things that they intend to do without worrying about the defensive engineering side. So we have two main offerings. One is Prefect Cloud, and the other one is Prefect Server. Prefect Server is a self-hosted version of our service where people would set up the server and the UI on their own infrastructure. And Prefect Cloud is our managed version of the offering. Prefect Server is entirely open source, and people can grab it from GitHub. Prefect Cloud comes with 10,000 free task runs, and people can get started by making an account through our self-service platform and release Prefect today. Because Prefect was designed for for the modern data stack, passing data between tasks is a first-class operation. In a lot of other workflow orchestration tools, data needs to be persisted at some intermediate location and then retrieved by downstream tasks. In some other workflow orchestration tools, data is needlessly replicated in order to transfer it between tasks. Prefect has first-class support for passing data between tasks. Prefect also excels in dynamic DAG creation. So during runtime, Prefect can dynamically adjust for parallelization and when it comes to mapping tasks on top of Dask. The other stuff in this list is stuff that you would expect from any other workflow orchestration tool. Prefect has support for parameterized flows. It has support for failure handling and monitoring. Prefect also has a GraphQL API that users can use to interact with flows. So the GraphQL API can be used to start a flow or to query past flow runs and see whether they succeeded or failed, etc. And one nice thing about Prefect is that it has full support for local testing. So people can easily test their flows locally before deploying them to the cloud. Here is an example of the UI of Prefect. The green bars represent successful flow runs, while the red bars represent failed flow runs. On the right side, the yellow bars are the scheduled flow runs that will be happening. The UI is very interactive, and it lets people easily identify the flows that failed, click into them, and find the specific task that failed, so that people know users know what to fix in order to get succeeding flow runs to work. With that, we'll move on to the basics of Prefect. So the main way to interact with Prefect is through Python code. Prefect uses flows and tasks as the semantics for workflow orchestration. Flows represent an entire application and are represented by directed acyclic graphs, whereas tasks are individual nodes inside those flows. So a workflow is comprised of tasks, and the directed acyclic graph illustrates the relationship of those tasks. Which tasks are upstream or downstream? Which tasks need to run in order for succeeding tasks to run? So on the right side with the code snippet, we have the most basic flow run, the most basic flow. So we have two Python functions named +1 and ×2. These are plain Python functions. And then we wrap them inside as a prefect task using the task decorator. Prefect is non-invasive to current code and easily wraps around current code, your existing code base using this decorator. Now that they become prefect tasks, we can use them inside the prefect flow. So we make the prefect flow context manager, and we name the flow basics. We then have X and Y. X calls our first task, which is +1. And notice that Y takes in X as the input into ×2. When you go to the UI, it sets a dependency between these two tasks. So on the top, we have +1, and on the second, we have ×2. And ×2 will take in the input from +1 because we passed it as a dependency. The next thing to discuss is parameters. So in our earlier example, we had an input of 0 into the +1, and then that was stored as the output of that was stored as X, and X was passed to ×2. But now we're interested in making our flow parameterizable. So we make a new parameter called input, and input has a default of 0, but now this input can be changed during runtime based on what the user wants. So the parameters can be set either through the UI or through the GraphQL API during when a flow run is being scheduled. So here the parameter takes in an input and the default is 0, and then that gets propagated down to downstream tasks. Next, we have failure handling. So notice the first task decorator. Here we specify the maximum amount of retries and the retry delay. Here we're specifying 3 retries, and if it still fails after 3 retries, then the flow will fail. Added to specifying retries on a task level, we have other mechanisms for failure handling. Number 1 is state handling. State handling detects the result state of a given task and then chooses what actions need to be done to handle that state. For example, if a task fails, we can create some kind of logical sequence in order to perform some other operations and then mark that task a success and continue the overall flow. We also have triggers. Triggers identify when tasks should be run. So we can say that even if an upstream task fails, we still want downstream tasks to trigger. If we have multiple upstream tasks, do we want to trigger when one of them succeeds, or do we need all of them to succeed? So Prefect has a robust set of triggers that identify when exactly a task should be run. The last thing is notifications. When a flow fails, we can programmatically email or send a Slack message to alert users of the failure. And then we can also have this during success. It doesn't matter. The point is that a certain state is being watched for, and when that state is triggered, then we send out the notification. I spoke earlier that Prefect has dynamic DAG creation, and mapping is the prime example of that. So here in this example, we have our parameter, instead of having a single value, now takes in a list, which can be seen here, of 4 values. Now the succeeding operations are performed for each of those items in the list because of the map operation. So now we're mapping this task over each set of input. Notice that we have 2 consecutive map operations in +1 and ×2. Prefect will apply these 2 operations for each of our inputs in a depth-first manner because of the Dask execution engine. So what's going to happen is that the 0 will be run through these 2 tasks, and then 1, and then 2, and then 3. But then, of course, if it were a sequential executor, we don't benefit from parallelism. So Prefect integrates with Dask in order to parallelize tasks. In this case, all I need is to specify the flow executor. And here I'm choosing the local Dask executor. And this will automatically be parallelized on the 4 cores of my machine. If I want to use a remote Dask cluster, all I have to do is specify a Dask executor and then point it to the address of that cluster. And it will run the flow on that, parallelized on that cluster. Now that we have gone over the flow basics and we're ready to register our flow, all we need to do is to change the last line from flow.run to flow.register. And the tutorial here is the project that our flow will live in. Here is what our flow will look like in the UI. So here we have our flow, which, if you remember, was named basics. And now we can easily run it by hitting this quick run button, or we can attach a schedule in the settings. As you may remember, Prefect runs on your hardware. So you need to resupply an agent, and the agent will pull Prefect Cloud or Prefect Server for runs that are scheduled to happen. And then once it sees that a run is scheduled to happen, it will pick up that flow run and execute it. So here, for this specific example, I performed a quick run, and I had my local agent watching for the flows. And I'll demo this more later on. So we know that Azure already has a workflow orchestration offering in Azure Data Factory. I'm going to illustrate some examples of how Prefect actually extends the function of Azure Data Factory. So for those who are unfamiliar, Azure Data Factory allows Azure users to orchestrate workflows for Azure resources. So in this example, I have a SQL Server database that I'm copying data from, and I'm copying it over to the Azure Data Lake. Once it's in Azure Data Lake, I have this Databricks task that will then run. And this Databricks task has Python code that will pull the data from the data lake, train a machine learning model, and then save the results of that model also somewhere else in the data lake. So first, we need to discuss how exactly you would call Prefect from Azure Data Factory. And the answer to that is the GraphQL API. If you remember, we have a GraphQL API where you can start flow runs, or you can query to check previous state. So all we need to do is to use this mutation up top. And we're using this create flow run mutation, and we're providing the flow ID that we obtained from registration. With that, we'll get a resulting output of a flow run ID. And the flow run ID is the ID of the actual flow execution. So after we hit this GraphQL endpoint, we'll start a flow run, and our flow will and our available agents will look for that flow, pick up that flow, and then execute it. So in order to integrate this with Azure Data Factory, all we need to do is hit that GraphQL API endpoint. And one of the ways we can do it is through the web activity task inside Azure Data Factory. So the web activity just hits a REST API endpoint. We can use, upon failure of our Azure Data Factory task, we can hit that REST API endpoint and then start a Prefect flow run in order to handle that failure. So together with Azure Data Factory and Prefect, we can combine these two to create more robust solutions that are capable of dealing with more complicated tasks. But before that, let's review the strengths of each one of these platforms. So for Azure Data Factory, it has built-in connections to Azure resources. Because of this, it's very easy to just drag and drop and connect and manage dependencies. One other strength of Azure Data Factory is that they manage compute for the users. So in the copy step earlier, where I copied from SQL Server to Azure Data Lake, Azure Data Factory was the one that was responsible for spinning up the workers and executing the task on those workers. Prefect, on the other hand, is a more general purpose framework. We showed earlier that Prefect allows users to have dynamic DAGs, especially with mapping. And there's also one I haven't covered, which is task looping, where we can loop over a task until it succeeds. Prefect allows for a lot of connectors and working with non-Azure resources, which I'll show later. And then Prefect has a lot more mechanisms for state handling. There are multiple different types of final states of tasks in Prefect. So for example, we can have skips, we can have failures, we can have pause, and pauses need to be manually triggered again from the UI in order to continue the flow. And then the last thing, which I haven't discussed yet, but it's a very important part of Prefect, is the hybrid model. The hybrid model essentially means that the orchestration of Prefect on the cloud is entirely separate from your internal code base and your internal data. So Prefect, even though it can orchestrate the task, your flows and tasks, it has no access to the data that you're working on, or to any of the environment that you're running it in. All we have is some metadata around the flow that you're running, and we use that to run the flows and the tasks. So the hybrid model means that you can manage your own compute on your own infrastructure. As long as it can reach Prefect Cloud, we don't need anything else. The hybrid model provides clients who need privacy and need a lot of security to maintain their workflows in their own environment, yet benefit from the cloud orchestration. So the first point of Prefect, which I mentioned, is dynamic DAG creation. So in tasks where we have a list of inputs and we need to perform some tasks over that list, Prefect would be the choice to go. So Prefect can be a subtask within Azure Data Factory, where if you have a list of, let's say, files, Prefect can perform operations on each of those files and perform them in a depth-first execution manner. In Azure Data Factory, this is a bit trickier to do because of the way that the DAG is constructed through the UI. The second thing Prefect does well is it integrates with a lot of non-Azure resources. So I manage the community Slack channel where I help people using Prefect for their own needs. A lot of the requests we get are people who are moving data from one source to another. Like for example, they want to sync their Postgres database with Snowflake, or maybe they want to use dbt in order to perform some ETL tasks. The point is, it's very easy to extend Prefect, and a lot of the pictures here are the pictures here represent the tasks that already exist in our task library, which is 90% community contributed. With the task library, it becomes very easy for a Prefect user to get up and running, combine a couple of tasks to perform their ETL job. So we also have a lot of users who are not as well versed in Python, yet there are enough building blocks for them to get started with Prefect. So what we can do from Azure is if a user has a lot of resources that are outside of Azure, like let's say there are databases that are inside their own network or inside on their on-prem infrastructure, we can use Azure to be the one to trigger the workflows and have their on-prem infrastructure be responsible for moving that data around. And the last thing that Prefect excels in is the hybrid model. So for users who need to use Azure Data Factory in order to orchestrate on-prem operations, Prefect is the perfect bridge for that. Because what we can do is have Azure Data Factory hit the GraphQL API endpoint of Prefect, and then Prefect would start a flow that lives entirely on the infrastructure of the user. So this is very important for industries that have a lot of privacy requirements, like finance or healthcare. Prefect is working on achieving SOC 2 certification, and we'll probably get it sometime this year. So now Azure can be extended in order to orchestrate on-prem operations. And with that, I'm going to do a demo of combining Prefect and Azure Data Factory. So quick, just a quick summary of what this demo will be. We have Azure Data Factory orchestrating a pipeline, and we want, upon failure of that pipeline, we want to trigger a Prefect flow. That Prefect flow will be comprised of a Slack task, and we'll get a notification on Slack of that failure. And we'll show why this is really easy to do in Prefect. So with that, I'll start with my demo. So the first thing to look at is the code. Notice, I said earlier that a lot of people can get started with Prefect even if they don't know a lot of Python. And this is a clear example why. We are going to import the Slack task, and we can easily pass a message to this Slack task saying that our Azure Data Factory pipeline has failed. And this will already be responsible for sending that message to our Slack channel. And then we're providing a webhook secret. This secret is stored on Prefect Cloud. And when this flow runs, it will pull that secret from Prefect Cloud and use this Slack webhook URL to send the message. So what I'm going to do is I'm going to register this flow using under the project ADF demo. Now I can go to Prefect Cloud, and I didn't have a flow before, but because I registered it, we're going to see the flow appear. So here's our flow that we just registered. And as a quick test, I'm going to hit this quick run button. And what we should see is I'm going to get a Slack notification telling me that a pipeline has failed. I have a personal Slack channel here that for an open source project that I'm working on. And what we're going to see is we're going to get a notification saying that the pipeline has failed over here. So now that we know that we successfully got this message that the pipeline failed, we can hook up this flow to Data Factory. And here I have a pipeline that this is the earlier pipeline where I copy a training job. I run a training notebook. And notice on the training notebook, I have this red connector. So the green connectors refer to success states, and the red connectors refer to failure states. So this means that I want this task to trigger when the notebook fails. So in order to get this notebook to fail, I'm going to provide a path that does not exist. And then second, I'm going to hit the GraphQL endpoint with this notebook. So this notebook is over here. I'm going to start the cluster. So in this notebook, all we're doing is we're hitting this GraphQL create flow run mutation and providing a flow ID. We just registered a flow. So I'm going to go ahead and get that ID and provide it to that script. So here in the overview, in the details, I'm going to see this flow ID for my ADF demo flow. And I'm going to copy that. And I'm going to replace this. Now this is good. I'm just gonna save this by running it. And then we should see another message pop up on Slack. This may take a while because of the Databricks cluster startup time. And then once we get the Slack alert, I'm gonna hit run this pipeline, have this fail, and then show that this alert will come into my Slack channel. So here we ran our snippet just to test, and I'm gonna see another notification come in Slack. And this is the second notification that came from running this notebook. So now all that's left to do is connect this failure handling to this training pipeline. And I'll trigger this now. And then we can go over to the monitoring tab of Azure Data Factory. And here, this will take a minute. Our copy step will succeed. And then our training notebook will fail. And then we'll hit the Slack alert and we'll capture this. So our copy step has succeeded, and now we're just waiting for this to fail. And upon failure, this will be triggered. So here's the failure state. And it failed because it could not find that notebook. And now our Slack alert got triggered. So now we're going to see once this completes running, we'll get a third notification inside our Slack channel because of the webhook. Our Prefect flow ran. So if we go over to Prefect, we have a scheduled flow run here that was submitted. Now it's in a running state, and now it's succeeded. And that's our third notification here. With that, we'll go back to the presentation. So I have a couple of conclusions left today. So number one, Prefect is a general purpose workflow orchestration tool. And we covered the basics of Prefect today, as well as showing the synergy of Azure Data Factory and Prefect. Prefect is good for extending Azure Data Factory to orchestrate on-prem environments, to extend DAGs in a dynamic fashion, and also to deal with non-Azure related tasks. And with that, I'm going to leave a few links to our GitHub repo, website, blog, as well as the community. And catch us on the Ask the Expert session this May 25, 10:30 a.m. PST. Thank you so much for watching.